Welcome to Nature with Aristotle, the show where we delve into the wonders of the natural world and uncover the fascinating stories behind the creatures and ecosystems that call our planet home. I'm your host, Aristotle, and today we're going on an underwater adventure to explore one of the most extreme and captivating environments on Earth, deep sea hydrothermal vents. Imagine yourself standing at the edge of a vast, dark ocean, with the water pressure so intense it would crush anything that tried to survive at such depths. And yet, in this seemingly inhospitable environment, life not only exists but thrives around hydrothermal vents. These underwater oases are like nothing else on our planet, supporting an astonishing array of life forms that have adapted to conditions that would be hostile to most other living organisms. Essentially, these vents are openings in the Earth's crust, typically found at mid-ocean ridges or back-arc basins where superheated water and minerals from beneath the Earth's surface are released into the ocean. This process is driven by volcanic activity, which creates a unique chemical environment that supports life forms dependent on chemosynthesis rather than photosynthesis. The discovery of deep sea hydrothermal vents in the 1970s revolutionized our understanding of marine ecosystems and the origins of life on Earth. Scientists like John Corliss and Jack Diamond were among the first to explore these environments, revealing a world teeming with giant tube worms, vent crabs, and other organisms that had never been seen before. Since then, research has continued to unveil the complexities of vent ecosystems, including the diversity of microorganisms that form the base of these food webs. From a scientific perspective, deep-sea hydrothermal vents are fascinating because they represent an ecosystem driven by chemosynthesis. Here, bacteria and archaea convert chemicals from the vent fluids into energy, which in turn supports a rich community of organisms. This process is fundamentally different from most other ecosystems on Earth, where photosynthesis provides the primary source of energy. Research findings have shown that these ecosystems are incredibly resilient, but also fragile in the face of human impact. For example, studies have found that deep-sea mining and overfishing can devastate vent communities, leading to a loss of biodiversity and ecosystem disruption. Moreover, the unique microorganisms found at hydrothermal vents have potential applications in medicine, biotechnology, and our understanding of how life might exist elsewhere in the universe. One of the most intriguing aspects of deep-sea hydrothermal vents is their ecological relationships. Giant tube worms, for instance, have no mouth or digestive system, but are covered in bacteria that provide them with nutrients through chemosynthesis. This symbiotic relationship is a prime example of how organisms can adapt to extreme environments by forming mutually beneficial partnerships. In terms of conservation, deep-sea hydrothermal vents pose significant challenges. These ecosystems are often remote and difficult to study, making it hard to monitor their health or the impact of human activities. However, efforts are underway to protect these unique environments through the establishment of marine protected areas and responsible management of deep-sea resources. These ecosystems not only expand our understanding of how life can thrive in extreme conditions, but also underscore the importance of preserving biodiversity for future generations. In conclusion, deep-sea hydrothermal vents are a remarkable example of the natural world's ability to surprise and inspire us. From their unique chemosynthetic basis of life to the intricate ecological relationships within these ecosystems, there is much we can learn from these underwater oases. Remember to like, share, and subscribe, and until next time, may your curiosity about the natural world continue to flourish.